All right, so we're going to get started. Today for exercise 203, we're still working on building up that critical skill set. Before I start turning you loose to model your own stuff, we're going to kind of repeat after me, for lack of a better way of describing it. But we have to build up those skills so that you're ready to set out on your own and do your own work. So we're going to continue. Today, my goal is to teach you a few really critical commands, some of which are, for some reason, people struggle with. Rotate 3D is one of them, and so I'll talk through how Rotate 3D works. Somehow getting your head around the Rotate 3D people struggle with. So we'll go through that and make sure that that is clear, I certainly hope. We're also going to use a command today called the project command, which I would argue, second to make 2D, which we won't cover until the end of the semester, is probably one of the most valuable things you can have in Rhino that is not available anywhere else. It's a really awesome command. And I'll show you how that works out in what we're doing today. For today's exercise, we are going to work with the same floor plan that we created last class. If you modified it, no worries, that's fine. If it looks exactly like mine looks, that's fine. If you've embellished it a little bit and finished it off, that's fine too. The point is that the more practice you have, the better. And so for today, we're going to work with the same piece, but we're going to bring it into 3 dimensions. Before we do the 3 dimensions, however, I do want to start by drawing the elevation of this building. And I'm not under the illusion that we're going to spend a bunch of time drawing fancy elevations or figure out roof pitches or whatever. That part doesn't matter. Essentially, we're drawing what the wall looks like. So this is when we refer to a Rhino file and we refer to elevations, generally straight up the y-axis is north. Generally straight down would be south, and then we have east and west to either side. So in this case, if I'm talking about drawing the south elevation, which is what we're going to start on, it's what we would see if we were standing right here at the bottom looking this way. That's the elevation that I'm talking about. And by elevation, I just mean the side view of this particular building. And so we're going to go ahead and draw it. Now, long term, and I'll show you this as we go forward, you might decide to just draw this on the side of the 3-dimensional object, or you might build it in 3 dimensions, kind of like a kit of parts. But I want to teach you Rotate 3D, and I want to teach you Project. Therefore, we're going to draw the elevation version first. So if you were in my 135 class before, this is very similar to what we did in the AutoCAD section, where we folded out an elevation and we drew the elevation below looking at our building. So in this case, I'm going to draw the elevation down here at the bottom of what I'm seeing if I were standing here looking this direction. So we'll draw using a polyline tool. I'll draw a baseline down here a ways. It doesn't matter how far away it is from the building. That is the same length as the building. Notice that I used my object snap to pull those 2 lines. I want to specify a height, so this would be the height of the wall. I'm not going to worry about floor plate and floor assembly or roof assembly. We're just dealing with the wall right now, so we'll do 8 feet. So I'll type 8, followed by the apostrophe for foot. There it is, and I want it going in that direction. Then I'll draw straight across, and I'll draw back down to right there. That looks a little bit taller, so hold on a second. That looks taller than I wanted it to be. Yeah, I think I made a mistake when I did it, so let me get rid of that, and I'll draw the top half again. Sorry about that. All right, let's try 8 feet again. Oh, so much better. Pull that up, and we'll come back down to right there. So that would, if I was looking at the side of this, I'd be seeing this shape. But I'd also have right here a line that divided that divided this step back in the building. So I have this piece coming out and that piece there. Make sense so far? Now I want to go ahead and I want to draw a little bit of window detail. So all I'm really concerned with is the opening for the window for right now. So let me go ahead and pull down a few lines to use as guides. So I'll pull one down here, and I'll pull another one. By the way, you can, in Rhino, right-click to repeat the last command. So sometimes I just do that, and I forget to tell you that I'm right-clicking to repeat the last command. So I'll bring those 2 lines down like that, and that gives me an idea of where the window is going to be. I need to draw the sill of the window and the head of the window. Typically, the head of a window is at 6'8", on an 8-foot ceiling. So I'll type 6 feet 8 inches. And again, if you do something different, it's not the end of the world. This is not a perfect thing. We're learning the skills, not trying to model. I mean, if this was the building we were building, it's awfully boring to begin with. So it's not about that. It's more about the skill set. So I've drawn that. And to repeat some of the commands and stuff that we've done last class, I'll go ahead and use offset now. So I'll type offset, or I'll go up to curve, offset, offset curve. Either one will get us there. And this time under distance, I don't know, let's say it's a 4-foot window. So I'll type 4 feet. And then I will offset this to right there. See how I created that piece? Now I could select these 2 lines because they don't really matter, and I'll delete those for right now. And then let me go ahead and fill in with a polyline just these pieces. I could have trimmed off the excess. I could delete them and redraw them. There's multiple ways of getting to the same place. Let me repeat here from there to there. And now I have this nice little window. It's very simple so far. So these, however, are all separate lines. And long term, I really want it to become one rectangle. So I want to join them back together into a polyline. And I can do that by going to the Edit menu and selecting Join. I can press Control-J. I could type Join, any of which are acceptable. It's going to say Select Object for Join. I'll select all 4. Remember, I'm selecting from my left, maybe, if it'll let me. Try that one more time. Oh, come on. What is going on? Sorry. I'm going to select them first and then type join. I don't know why it wasn't letting me select. 4 curves joined into 1 closed curve. That's what I was after. So when you do a join, it's always useful to look up there at your command line and make sure it worked. So I had 4 curves. They're joined into 1 closed curve, which is exactly what I want. So now I have this particular piece. Let me go ahead and offset it so I have an inner piece of glass, for example. So I'll go ahead and type offset. Or I could go up to curve, offset, offset curve. My distance this time, I don't know, 1.5 inches, something like that. And we'll make a little frame that's inside the other frame. I could take it a step further and make a little bit of trim that goes around the outside. So we could repeat the offset, curve, offset, offset curve. And maybe this time my distance would be 3.5 if it was a 2x4. And I could offset that outside. So you see I'm kind of building up what the window would look like. So I have the frame there. I have the frame of the window itself, and then maybe a piece of glass. Now, I happen to have more windows. So let me go ahead and take this, and I want to make a copy of it right next to it. So I'll go in and I'll type copy. I could also go up to transform copy. Remember, this isn't an edit copy, it's a transform copy. So I type copy. I want to copy from right here. We'll move it over to right there. Perfect. And now I have 2 little windows. Now in this case, I have a little bit of a problem. See how those 2 overlap? I don't really want those to overlap. So I'm going to go ahead and take these outer pieces on both sides, and I clicked one, held down Shift on the keyboard, clicked the other one. I'm going to type explode. Basically, that's the opposite of join. It makes all of these separate little line segments. And so I'll go ahead and get rid of these lines and those lines. I'll press delete, and I'll draw a new line that goes from here to there, and from there to there. Okay, so the trim just, instead of overlapping, it cleans it up a little bit. In reality, I should change the plan so that those windows are a little further apart so we didn't have to worry about it. But yeah.
Will the mirror function work the same way to mirror?
Yes, the mirror function would work exactly the same, except you'd have to find your mirror point. So what line is the mirror point? And to me, that's harder to find than to do the copy. So it's doable. It's just a different way of approaching it. So let me go ahead and do the same thing over here. I'm going to draw these 2 windows. So remember, everything's about repetition. So this time, I already know where the head height is, and I know where this point is. So I'll use my smart tracking there and right there on that point, maybe. Oh, come on. Let me zoom in a little bit here. There we go. Smart track to the intersection right there. So tracking from those 2 points, I can draw over from this point to right there. Now I can draw down to match up with this point. Come on, set the point. Sometimes they just don't want to set for you. There we go. Pull it over till that matches. There. Pull it down till that matches. That was not good. And C for close, so I close that shape. So I'm just using smart tracking instead of pulling my guidelines. It doesn't matter how you do it. And I'll do the same thing to set this one up. So I have my closed curve here. I'm going to go to curve, offset, offset curve. And this time my distance, I'll say maybe is 1.5 again. And we'll offset it to the inside. Then I want to offset it to the outside. So I'll repeat curve, offset, offset curve. Distance this time we'll do 3.5. And we'll offset out like that. So now I have this little picture window. We'll go ahead and copy this one. Copy, or to transform, and then copy, either way. And we'll copy from right there to right there. So in your question about mirror, I would have to mirror it right in the center. And it's possible that the midpoint is there. On this one, the midpoint wouldn't be there. So I could mirror it instead. OK, so we have to do a little cleanup of those 2 pieces of trim. Same problem. Again, I should move the windows further apart. Explode. Let's clean that up. I'll just delete them. It's easier to draw a separate new closed. So we'll go there, and we'll go right to there. OK, so now I want to go through and make sure everything's joined up so that they're all closed curves. So for example, this one here, I need to go through. I'm holding down Shift here to select it. And then we'll go back to Join. Remember, it's also Edit, Join. I'll do the same thing over here. I think I forgot it. Oops. Edit, Join. OK, so I have there. That's closed. That's closed. That's closed. That's closed. That's closed. Perfect. That's closed. Just kind of confirming before I move on. Perfect. Now, I could add mullions to the window. I could add more detail. But this really isn't about the detail. It's about the process. So you're free to add as much detail as you want. You want to make a rounded window at top. That's fine, too. You've got plenty of flexibility for those kinds of things. But let me go ahead and continue on with what we're trying to do. So the first thing, as we move on, is we're starting to get some complexity to our drawing already. We have a line floor plan. We have a line elevation. When we start to create three-dimensional objects, we need some clarity. So I want to introduce right now the layers panel. And so this is similar to layers in Photoshop, InDesign, Illustrator, AutoCAD, SketchUp, etc. Although people tend not to use layers in SketchUp, but that's a side note. But in Rhino, their layer structure is very robust, and it's worth kind of getting organized early in a file. Like I said, on your final project, I wouldn't be surprised if you have at least 100 layers, if not 1,000 layers. I mean, there's a lot, and that's to be expected. So over here on the right side, I'm going to click the Layers tab. If for some reason you're not seeing this, I believe it's available under, you know what? I forget where it is. Panels. There we go. Panels, and you can check the box for layers. But again, it's already showing up on the right side there. And if we look here at the layers, we've been currently working on something called the default layer. We can tell that it's default because it's black and our lines are black. Of course, if we had more layers that were black, it would be confusing. So we're currently working on the default layer. There are also layers 0, 1 through 0, 5. For right now, I'm going to go ahead and get rid of all these other layers, and we'll create brand new ones. So I select the first one, select the last one by holding down Shift. Everything in between is selected. And then I can press the Delete button, and now I just have one layer. So let's rename this one layer that is currently default. Let's rename it to Line Drawing, or Line Drawings, something like that. Now, one of the great things about Rhino is that you can nest layers. You can create sublayers. So underneath Line Drawings, I'm going to create a sublayer. It's the one with two little icons. And you see that now I have a plus sign and then a sublayer. We'll call this Plan. I'll go back to line drawings, create another sublayer, and we'll call this elevation or front or whatever works for you. Just because I call it plan or elevation doesn't mean you have to call it that. It just, for clarity, it's something that you need to understand. So I have line drawings, I have plan and elevation. Now I want to change and make sure that my plan, I'll select from left to right, is on the plan layer. If I right click on plan, I can say change object layer, and it moves to being on that layer. I'll select from left to right my elevation. I'll right click on elevation and say change object layer. There it is. So in this case, everything is black, but I could turn off the elevation. I could turn off the plan. In Rhino, there's no difference. Like in AutoCAD, there's a freeze and thaw, and there's an on and off. In Rhino, there's just on and off. Okay? There is also the ability to lock a layer so that you can't edit it if you want to. I rarely use locking in Rhino, but be aware that it's there. So I have line drawings, I have plan, I have elevation. Let me create a new full layer, so not a sublayer. And this one, I'll say 3D walls. Now, I want the 3D walls layer to become my current layer. The line drawings layer is my current layer because it has the check mark on it. I'm going to double click on 3D walls, and it's going to get the little check mark there, and it's going to become the active layer. So the other thing about nested layers in Rhino is you can click the little minus sign, and they retract up into their nest. You can nest within nests within nests. So you can see how this can expand and contract really nicely for a large, complicated drawing. OK, so now everything we've done so far is all flat in 2 dimensions. And we want to start seeing this in 3 dimensions. So I'm going to switch from the top view. So I'll double click on the top view right here. And I'm going to double click on the perspective view so that we can start to see this whole thing in perspective. Now remember, as part of this, if I want to orbit around my object, I just right click and hold, and I can orbit around my object. So a little different. Those of you that are comfortable with SketchUp, this is going to throw you off. And it'll throw you off backwards when you go back to SketchUp after working in Rhino, because they're different. So in our case, it's right click to orbit. There we go. Now, nothing is in 3 dimensions yet. If I get down here really flat, you see that it's all still flat. But I want to take this wall, or this south elevation on the elevation layer, and I want to get it standing up. Okay, so it's still lines, but I want to get that standing up. So what I need to do is I need to select the whole wall. There it is, so it's selected. And I'm going to use a command called rotate 3D. And in the world of Rhino, we have regular rotations, which is, as you would expect, on the ground, you rotate one object. So let me show you a quick illustration here. All right, so there's an object. If I use regular rotate, so if I go to transform and then rotate, essentially I pick a base point, and then I can rotate this object around that base point. Okay? What rotate 3D does is it essentially says now the rotate can happen in any direction at once. And so I will select this wall. Oops, let me orbit just a little bit there so I can select the whole wall. And now I'm going to rotate 3D. So it's again available under the transform menu, rotate 3D. You can type in rotate 3D. Remember, just as a reminder, on the handouts, when you can type in something, I put it in that typewriter font just so that you guys can see that that's a typable command. So if I type rotate 3D, or I go to rotate 3D, I'm going to look at what the command line is telling me. So what it's telling me is, what is the start of your rotation axis? So because we're doing this in 3 dimensions, we have to think about what axis are we trying to rotate around. So you can envision this as what line. If I could draw a line in space, where is that line that I'm going to rotate around? So in this case, the line needs to happen right at the base of my building here. So my axis of rotation starts here on the building. It ends, end of rotation axis. It kind of doesn't matter. It could be somewhere off in space. But for right now, we'll end it right here on the edge of my building. Then it says angle or first reference point. So my first reference point, the easiest thing to do would be to go along this side and specify it. Now Rhino gives us a nice little helping circles so we can kind of see in 3 dimensions where it's going to rotate. So in this case, I'll rotate from that point. And if I didn't have ortho turned on, you can see that essentially Rhino will let me rotate this anywhere around that axis that I specified as my rotation axis. Make sense so far? So because I want it to be pointing straight up, rather than trying to guess where straight up is, I'm going to turn ortho on, and then it snaps either to flat or straight up. And so in this case, I want it to go straight up. So I just make sure that I'm not snapping to anything, and I click. And so now the line that was flat is now standing up and down. Now it's important to recognize, like as we're looking at this, depending on what angle you look at it, it kind of looks like it's leaning out. Do you guys see that? That has to do with the perspective that we're looking at in our view. If I were to change my view out of perspective to have parallel projection, let me deselect for just a second. It would be more an isometric view, and it would be easier to see that, yes, it is straight up and down. So it's a view. It's kind of like when you're working in SketchUp and you do a box and suddenly it looks like it's too long, but it's actually a square. It's the perspective view skewing it just a little bit. So to me, I have a really hard time modeling in parallel projection. Somehow perspective just seems like it should work better. So we have our windows and our walls up in the 3rd dimension. We have our floor plan living here, but what we don't have is any actual 3D objects just yet. We just have lines. And so it's time to start creating our 3-dimensional objects. And so what I want to do to create these objects is I want to do an extrude of some lines. But before I do the extrude, I want to look at my floor plan and make sure that it is a closed, continuous line. And this is where people run into trouble. If, for example, you added the little room that was here, like this. Obviously, I didn't finish the room, so bear with me for just a second while I do it. You may have found, oh, I need to cut the door in it. Hold on just a second. OK, so you may have found, oops, I put that in the wrong spot. Sorry, little details can bug you. OK, so you may have done this, where you added that little piece. And you need to go back and confirm that everything is, in fact, connected together. So I want to make sure that this and this and this and this all connect together. I'll type join so that they're together. 5 curves joined into one open curve. That's good. That's what I'm looking for. I still need to add these pieces in. There, there, and there. And I'll type join. 4 curves joined into one closed curve. That's essentially exactly what I'm after. Okay? So it's one nice closed curve. If you don't have a nice closed curve, when you do the extrusion, you're going to end up with surfaces that are on top of each other. And it doesn't really matter for what you're doing right now, but it'll end up being complicated down the road when you try to render. So we want to make sure that that's nice and clean in advance. So the doorways are cut out. The windows are not. It's one continuous closed curve. And now I'm going to go ahead and do my first extrusion. So let me go up to extrude. It's under Surface, Extrude Curve, and we're going to go straight. The key command for it is Extrude CRV, which is also available on your little handout. And now we see that I'm starting to get a 3-dimensional object here, which is exactly what I want. Now, a couple things, though, before we get into the extrusion distance, which I'll type in just a second. We do want solid to be turned to yes. If we leave solid turned off, we will not get a top for the wall or a bottom for the wall. We'll just get the two sides. So we're going to leave that, or we're going to say solid, yes. Delete input is also something that's important. And so because we created a separate layer, we can turn off the curves long term. But there will come a point when you're doing extrusions where you have a curve and you want it to become a 3D object, but you don't need the curve that it came from down the road, so you can choose to delete that curve that it came from because you don't need it. If you're extruding a poly surface, a lot of times you want to enable this so that it gets rid of the original surface. I'll explain that more as we go. Okay? The rest of these are all fine. Both sides is exactly like an offset. It would be extruding both directions at once. We don't need that, so we're good. The only thing I need is my distance. So in this case, it should be 8 feet. So I can type in 8 feet and enter. So now I have my actual three-dimensional object, but it's still showing up just as lines. So let me go in and switch. Right here next to perspective, I'm going to click on this little triangle, and I'm going to switch from wireframe to shaded so that I can see this as if it were a nice little solid object. So we do have a few little problems, one of which is at the doors because we don't have the tops to the doors just yet. So we're going to have to deal with that. But for the most part, it turned out pretty nice. Okay? There is an extra little line here because of how I drew this curve. It doesn't matter. When you render it, that line will go away. Okay, so now it would sure be nice if I could take this window and put it on that wall. And you guys had to deal with this a little bit in SketchUp if you took my version of 135, where we tried to like move this close, or we tried to draw little guides or whatever to create this window. Rhino has something called the project command. And at this stage of the game, it's a little, you haven't used Rhino enough to understand how valuable this command really is. But what project actually does is it takes some curves that are floating out in space and it throws them at your building and draws it on your building, in this case. But we could extend that. It doesn't have to be a flat surface. So let's say you had a footprint of a building that was on topography or terrain. You could have that footprint. You could project it down onto the sloping surface, and it would trace right along the sloping surface the outline of your building. So it's a really, really good command for the kinds of things you're going to be modeling. But it's a little tricky to make it work. So in order to make the project command work, we need to initiate the project in the view that is perpendicular to the direction that we want to project. So I'm going to look at all 4 views at once right now. And in this front view right here, I'm looking at the windows, and further back would be the surface itself. So I need to be in a view with the direction perpendicular to the way I want it to go. And then I can actually select, and I'm just going to start with the basics. I'm going to start with these first. Actually, I'll just do one window to start. I'll pick this one curve, and I'm going to project that one curve onto the building. So again, I'm in the front view. It's the active view. If you need to switch views, you can click on front. If you happen to be in perspective, you can click over to front. Make sure you're in the front view. When I'm in the front view, I will type project, or I will go to, sorry, I never go to it from here. Curve from objects, project. So curve from object, project, or you can type project. And it's going to say select surfaces, polysurfaces, and meshes to project onto. So in this case, I want to project it onto my building. I select it. Notice that the selection happened in the front view, not in the side view. And I'll show you how this doesn't work in just a second. So I've gone ahead and I've selected it. I'll go ahead and press enter. And it then takes that rectangle and it throws it out across the 2 surfaces in a straight direction. So I could repeat it using one of these. For example, I could go project onto this surface, and it'll throw those. It puts them on both surfaces of the wall that it goes through. So they're on the front side and they're on the back side. Okay? The temptation, however, is to be in the perspective view and say, oh, I need to do the projection. Okay, well, let me go ahead and take this line here. I'll project it over here. Project. Great. I'll project it onto this. Perfect. Oh, wait, it didn't work. And that's because the projection missed the selected objects. Because remember, it's projecting perpendicular to the view. So right here, I'm looking straight on. If I were projecting that straight on back, it's not intersecting anything. So we have to make sure that the projection occurs in the view that's perpendicular to the way we want it to go. Yeah?
Just a quick question. Does it matter which order we select the objects that have to be projected?
The objects that are to be projected have to be selected first. The object that you're projecting onto is always second. So in this case, if I have nothing selected and I type project, it's going to say select curves and points to project. So it's prompting me. The curve to project would be that curve. I'll hit enter. Select surfaces to project onto. It would be that surface. I'll hit enter. And now I end up, again, in the perspective view with those curves as well. So I have one more. This curve here needs to be done. So I'll go back to my front view here. Project onto this surface. There it is. And in this case, notice that it projects kind of half a window over here. I don't need that half a window anymore. So let me hold down Control. So this is something else that happens in Rhino. Adding things to a selection, you press Shift to add. If you press Control, you can deselect things, which is really useful if you accidentally select the wrong thing. So I'll press Control, and I'll deselect those two objects. Now I can press the Delete key, or type Delete, and that piece goes away. So I've taken the flat drawing that I did, I've rotated it into the third dimension, and then I've used the Project command to actually outline where this is going through my building. So at this point, there's two different ways. Obviously, these windows aren't actually cut through the building just yet. And it's not as simple as using the push-pull tool and dragging them through like you would do in SketchUp. So we have to do a little bit of work. There's two different ways of going about this. Some are easier than others. Sometimes you have to use one or the other. I'm going to show you both, and I'll show you both back to back. The long-winded way of doing it would be to select this curve, orbit around, and select this curve. Use the Trim command. So I'm going to type in Trim, or go to Edit and then Trim. I'm going to select those two pieces and cut my hole through my wall. I'll hit Enter to finish. Now remember, I talked about this before. Even though the objects appear solid in Rhino, they're actually hollow inside. So we can actually be inside the wall if we want it to be. That's the way Rhino works. So in this case, I've cut through the wall, but I need to connect or create a surface that goes all the way around. So I'm going to use Loft to do that. I'll select the first one and the outside one. Hold on one second. And then I'll use Surface Loft. We'll hit Enter with the default options, and it'll then fill in the inside jambs of the window. Yeah? Not in this context. Not in this context. Patch needs a curve that goes all the way around. So if you drew a curve that went across and you exploded the curve that went around, you could technically make it work. So patch wouldn't work. What was the other one? Cap. Cap, I think. I'm not sure if cap would work. I generally don't think of it as working on something like this, but we'll just give it a shot and just see. Yeah, they're not. Yeah, I don't think it'll let us do it. No. It fills it in instead. So in this case, Loft is our best bet. Good questions, though. So Loft, Enter, default options. There we go. And now it fills that in for us. This certainly works. There is a slightly faster way of doing it. And it's going to be using a command called make hole to basically cut a hole through your building. In order for the make hole to work, your hole, or your curve that represents the hole that you want to cut into the side of your building, must be coplanar with the surface that you're cutting through. So it can't be skewed. It can't be, I couldn't make a hole with this curve that's out here. It needs to be on the surface itself, which is why the project command is great, because we know it's on the surface. So make hole is available underneath the Boolean operations. So right here, there's two little spheres that are connected together. We're going to click on the triangle next to it to see all of the options, and we're going to come down here to the make hole command. It's like second row from the bottom, second row from the right side. And I'll click on Make Hole. It's going to say Select Planar Closed Curves. That was what I was just talking about. There's my planar closed curve. I'll press Enter when I'm done. Select a surface or polysurface. My surface or polysurface is right there. Then it says Select a depth. So in this case, I want to go all the way through my wall. So we'll snap to the back side of the wall here. And I'll click, and it will then cut through that particular piece. So it saved the loft. I didn't actually have to do the loft. It made that for me. So I'll repeat that whole thing one more time over here for this window. So once again, I'll go into my Boolean operations. I'll come down here to Make Hole. I could also type Make Hole. Select Planar Closed Curve. Okay. Now I'm going to do both of these at the same time to save a little bit of time. I'll go ahead and hit Enter. Select a surface or polysurface. There's my surface. Select a depth point. I want to go all the way through the wall. And I've now cut those two through as well. So you can see it's pretty efficient. It's fewer steps to try to do. Therefore, it's good. Sometimes you'll run into snags where your whole curve isn't coplanar and it won't let you do it. Sometimes it won't go all the way through your wall and you'll end up with an extra surface. So there can be issues along the way. For the most part, it works pretty well. So let me do these back ones. So I'll take those two there, Make Hole. There's my surface. Now notice that if I just go back just a little bit, let's see if I can go back a little bit there, it will do a recess, like a little niche, instead of cutting all the way through. So the only way I'm going to get it to cut all the way through is to specify the back side of the wall. So there's the back side of the wall, and now that cuts all the way through there as well. So one more time back to the old way of doing it, just in case. I'll select this curve. I'll come over here and select that curve. With both of those selected, I'll press Trim or go to Edit, Trim, and then I'll click on the surfaces to cut through. I'll press Enter when I'm done. Now notice Rhino keeps those two curves still selected. It never deselected those, so I can go immediately into the loft. I'll go to Surface and then Loft, or type Loft. I'll press Enter twice to get through the options, and now I've filled that in as well. So it's not that much slower. Okay? So I was able to cut through all of those holes for the building. I do need to make the heads for the doors, so I can do that using just a standard shape. So I'll use a box. I'll go from one side to the other side. My height needs to just come down and match the height of the window there. I'll do the same thing over here, there, and we'll come down and match the height of the window, and there. And essentially, I was able to create this particular shape. So I can take it further, and I'm going to do a few things to show you some evolutions of these, just so that you're aware of it. But if you get this far, I'm really happy. That's a good thing. Okay? So if I were to take this a little bit further, if I were to make this a little bit fancier, maybe I'd want to put the trim around a window, for example. So let me go ahead and project that curve. So I'll go back to my front view, making sure I'm in the front view. I'll type Project. I'll project that curve onto this surface. There it is. Remember, I don't care so much about the one in the back. We can get rid of that one. I'm working just here. There's that little piece. So in this context, I'd like to make the little bit of trim, but I want it to stick out from the hole. So I can use the Make Hole in the opposite way. So let me use Make Hole again. Select Planar Closed Curves. There it is. Enter. Select Surface or Polysurface. There's my surface or polysurface. Now, thus far, everything that I've done, I've been punching back. This time I want it to come out a little bit. So let's do maybe 1.5 inches. And it conveniently didn't do it for me. How nice, right? So let's try it a different way. It made the trim, but it didn't extend it out for me. So instead, let me take this curve here, and I'm going to do a split with it. So I'll type split. Oops, sorry. Wrong order. Split. Select objects to split. We'll take this surface, and we'll split it with this piece right there. That gives me a separate. Isn't it fun when stuff just totally doesn't work? Right? Isn't that always good? So we'll do it yet another way. I'll just go ahead and draw on it, because for whatever reason, it's not liking me. So let me take this, and this, and this, and I'll extrude those curves. See, that's the thing about Rhino. There's always a different way of doing it. So for whatever reason, my initial ways weren't working. So let me go ahead and just extrude curve. In this case, I do want it to be a solid. Yes, I don't want it to be both sides. And I want to specify how far. It will be 1.5 inches. I do want it to delete the input. So I'll go ahead and choose delete input. And oops, 1.5 inches. And it keeps doing it backwards. So because I'm going negative y instead of positive, I should have typed negative 1.5. So let me just move that out. That's where I was having a problem with the make whole. So let me drop that out like that. And now I have the extra little piece of trim that goes around the window. We'll get into more details about how you do this kind of stuff, but I want to kind of illustrate how this stuff starts to join together. So it's the same extrude that I just used. Let me do it one more time for the fun of it. Over here on this window, project onto this surface. There it is. I'm going to take this curve, this curve, this curve, and I'm going to project, or excuse me, I'm going to extrude curve, which is also available under surface, extrude curve straight, if you want to get to it that way. And I want to make sure that it is solid, yes. Delete input, yes. This is going to be negative 1.5 inches this time, so I do it correctly, and it's going to stick out for us like that. Okay? So this is going to take practice. The key thing today is understanding rotate 3D, understanding extrude, and understanding project. If you get those three things down, I'm very, very happy. When you're done today, set yourself up with a reasonably nice view, something like that. Remember, you can go in and you could turn off, oh, I don't want the elevation anymore. Let me just go ahead and turn that off. We'll make that a little bit bigger there. I'm going to go to this little triangle next to perspective. I'm going to go to capture, to file, and I'm going to save a JPEG image of this exercise 203. So let's call this EX203. And I'll go ahead and save it. That then gives me an image file that I can post for today. I also want to make sure that I save this file. So I'm going to do a file save as. And we're going to go into today's folder, 203. I'm going to rename this 203. And I'll click Save. That means I have the Rhino file. I will ask you one more day to bring this up. We're going to deal next class with kind of an introduction to V-Ray in a little bit more depth about how materials work. And we'll come back and visit putting materials on this particular building at that point in time as well. Are there any questions? I know it's a lot to try to take in, but at the same time, we have to get started somewhere. And so I try to get these scripted so that you can get through them and you can work from there. Wait, I got two of you at once. Sorry. Go ahead. OK, I'll come and help you join the walls. Oh, if you want the grid bigger. So if you don't like, if we're looking down at the top view and you don't like this grid the way it is, if you right-click on, I think it's on Grid Snap, you can go to Settings. And it's going to bring you to the grid settings. And we see right here grid properties. Grid line count, how many? Minor grid lines every 1 inch. Major grid lines every 12 inches is what it's set for right now. So if I just take the grid count and I drop another 0 on it, I'll have a much larger grid, for example. Okay, so it's very, very easy. It's just a right-click there. I'll help you through on why they're not joining together. Chances are something overlaps, and that's the problem. But we'll go through and figure it out. Any other questions? No? All right, good deal.